Welcome back to the YouTube channel. Today we're going to be looking at some close by stars to our sun. I know you may be thinking, I did this 4 years ago when I was in 3rd grade. Well, I did, but this is a remastered version, so I'll be giving you more details about stars close by to us, because last time some of the stars were not that close by to us. So we're just going to be looking at a 15 light year radius for close by stars to us. So let's go to the star browser. You may have seen how do you use the star browser. You can check it out here if you haven't seen it. But basically we're going to set the radius to 15 light years, and we're going to pick up any stars within a 15 light year radius. Some stars. We're going to be picking some top 7 stars which are 15 light years away from us. Let's click on it, and you can see a lot of stuff you can see here. So the first thing we're obviously going to be doing is the Alpha Centauri star system, like I did 4 years ago. So you may see, this is from the movie Avatar, remember? But A Centauri is a yellow dwarf main sequence star. A Centauri A is a yellow dwarf, while A Centauri B is an orange dwarf. It's part of a binary star system. Meanwhile, this is just A Centauri, but it's part of a 3-star system. Another star close by is Proxima Centauri, home to 3 real exoplanets: Proxima D, Proxima B, Proxima C. Proxima D and all of these, actually 2 of them are tidally locked. This one is a lacustrine. We don't know exactly what these type of planets for the exoplanets are. Well, this is what Space Engine gives. This is Proxima Centauri. So now we're going back. It's a closest star to us, and the second closest is Alpha Centauri. The third closest to us is Barnard Star, which is home to Barnard Star B, and it is not a planet with life. Some people think that it is just rather a lacustrine, which is like not have life at all. Here are some procedurally generated stars, but we don't care about this because apparently we're looking for real stars this time. And that's going to go. This is Captain Star. It's a red subdwarf. Yes, a subdwarf star. And it's home to Captain Star B and Captain Star C. They're both terrestrial planets, which one of them is tidally locked, and it is just a star, I guess. So Captain Star is 11 light years away from us, while Proxima Centauri is 4 light years away from us, and Barnard Star is 5.8 light years away. This is 11.8 light years away from us, and it's a red subdwarf. Diameter 404,000 kilometers for Proxima Centauri. It is about 214,000 kilometers, meaning it is slightly larger than Jupiter. And Barnard Star, which is another one, which is about 200,000 kilometers, and that's all. Now we're going to be going through some more stars. We have now went through about, let me check, 1, 2, 3. Here's 4 stars right now we've went to. So now we're going to be going to a star that you may have heard of, which is a white main sequence star. And that's right. I'm just going to find it. Hold on. And let's search it up. It's Sirius. Sirius is a white main sequence star, but it's actually part of a binary star system. Sirius A is a white main sequence star, but its counterpart is actually a dead star, a white dwarf. Yes, so that means Sirius B, judging by its age, it could have been the larger of the two, meaning Sirius B used to be larger than Sirius A. Maybe was a B-type main sequence star, until it burned up its fuel, turned into a red giant, and eventually became a white dwarf star. And that's what happened to Sirius B. Kind of a sad story for Sirius B, but for Sirius A, it is still living for another hundreds of millions of years until it will also turn into a white dwarf star along with Sirius B. And the diameter is about 2 million kilometers larger than the sun. Sirius B is slightly larger than Earth, but it's a white dwarf star. Its temperature is 25,000 Kelvin. That's a lot. But it's normal for white dwarf stars. And here's now, we have now gone through 5, I think. We are going through 2 more stars that are close by to us. So now we're gonna be talking about Lyon Star. It's home to 4 planets, also known as Gliese 273. Lyon Star is a M dwarf, or a red dwarf star, 407,000 kilometers, meaning it is a very high spectrum red dwarf, and it's home to 4 exoplanets. Gliese 273, or Lyon Star C, B. You see, C is actually closer than the B, because apparently it is. And then after that, it's D, which has a very high actual tilt. E, which also has a very high actual tilt. And 2 of them are just tidally, and this one is tidally locked. This one isn't. So let's go to one of its exoplanets. Gliese 273b, also known as Lyon Star B, is just a super oceanic planet. It does not have life, obviously, because even though its ESI is 87, it does not have life. It's a super oceanic planet, and it's one of the only planets in its system that's tidally locked. According to the space engine, it's not actually accurate when it comes to knowing what the true meaning of exoplanets are. Now we're going to be going through the last star, which is a white dwarf star called Van Manen Star. Van Manen Star is a white dwarf, and as you can see, if you see planets here, these are procedural, so Van Manen Star does not have confirmed planets yet, but it's a white dwarf star, which is about like 20 light years away from us. It's actually 14 light years away from us, almost 15 light years, and it's actually 6,000 degrees Kelvin. It's kind of cold for the white dwarf. So that's 6 stars. Make sure to subscribe, and I'll be going through interstellar space to conclude the end of the video. You can click off anytime. Bye bye, everyone.